Hello everyone and thank you for joining us in this HFWorks webinar. In this webinar, we shall show you how to study the power handling of high-frequency electronic products using HFWorks, right inside SOLIDWORKS. Our agenda is as follows: a brief discussion about our products and services, followed by the main technical presentation. After the technical presentation, we will brief you about licensing, services, and various learning resources offered by HFWorks. Then comes the questions and answers period. At that point, Dr. Kabir will go on stage and answer your questions. You may then type your questions in the chat section. All of your questions will be answered. All of our products are integrated into SOLIDWORKS, the #1 3D CAD package. Some of our products are equally integrated in Autodesk Inventor. Why? There are a couple of reasons, including, we want to concentrate our effort on what we know best. Electromagnetic simulation. We don't want to reinvent the wheel. In other words, why should we develop a CAD while there are excellent professional CADs? Developing a CAD requires much more human and financial resources than a simulation software like ours. Indeed, all simulation companies that made the mistake of developing their own CAD ended up with a primitive and even mediocre software. Why bother about learning a new primitive CAD? Just use your professional CAD and start simulating right away. You can easily collaborate with other departments in your company since all of you use the same CAD model. Some companies that have their primitive CAD claim that you can import files from popular CADs such as SOLIDWORKS or Inventor. It is true, you can import. However, oftentimes you would need to heal, stitch, or clean the geometry because of compatibility issues. Furthermore, if and when you need to make the smallest modification, you must start all over again. We hope that you understand now why we stayed away from developing our own CAD and, instead, relied on the professional CADs. We believe that we convinced you. You may ask now, what are the other companies that provide an electromagnetic software package that are fully integrated in a professional CAD such as SOLIDWORKS or Inventor? Look no further. HFWorks is the first and the only company that provides electromagnetic software as add-in to SOLIDWORKS and Inventor. As a matter of fact, the integration in SOLIDWORKS dates back to 2007 and in Inventor to 2012. Consequently, we have more products integrated in SOLIDWORKS which are all gold certified. Our products and services are as follows. EMS is a 3D electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers many applications like insulators, cables, bus bars, permanent magnets, actuators, circuit breakers, transformers, and motors. HFWorks is an electromagnetic simulation software for RF, microwave, high frequency, and high-speed electrical and electronic devices. It covers many applications including a wide range of antennas, resonators, filters, connectors, and waveguides. HFWorks 2D is a 2D and axisymmetric electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers the same applications as EMS. Motor Wizard is a template-based motor design software. It offers analytical and finite element analysis for BLDC and permanent magnet motors. In addition to these solvers, we offer several multi-physics modules including motion, stress analysis, thermal analysis, electric circuits, and ECAD. Let's move now to the feature technical presentation.
Welcome again to this HFWorks webinar, Power Handling of Electronic Products. Let's first define the power handling of an electronic product. It is the power level that an electronic device can support before it fails. Failure can occur abruptly due to dielectric breakdown that results in arcing when the applied power is too high or if the spacing, such as an air gap, between components is too small. To protect electronic devices against dielectric breakdown failures, systems are usually designed with a safety margin such that they operate in a dynamic range well below the damaging power levels. Borrowing from structure engineering, we introduce a safety factor. It is equal to the electric field strength divided by dielectric breakdown field in volts per meter. Hence, if the safety factor is less than 1, no breakdown occurs, and vice versa. It is easy to remember and more convenient that using the electric field strength. We will use the example of a comb line filter. As many of you know, comb lines are a variety of filters that use wavelength capacitively loaded rods as resonators, offering a low loss, rugged and compact design. Comb line filters are narrowband, used in situations where closely spaced signals need to be separated, usually found in high power applications. Hence, they are prone to breakdown. Since HFWorks is an add-in to SOLIDWORKS, the #1 3D CAD software, the creation and modification of the geometry is as easy as a pie. Therefore, we skip the geometry creation part and dive straight into HFWorks. Since the comb line filter is a closed structure, the S parameters module of HFWorks is invoked. To add a new S parameters study, right-click on the project name and choose S parameters. Give it the name of power handling. Under the General Properties tab, check the Save 3D field data and compare fields to breakdown level. Click on the Frequency Sweep tab and choose Fast Sweep from the pull-down menu. From the Frequency Unit pull-down, choose MHz. Enter 880 for the start frequency and 894 for the end frequency. Enter 101 for the number of frequency points. Click on the Coupling Analysis tab and check thermal coupling. Click on the Meshing tab and take the default adaptive meshing and click OK. A new S parameters study is added to the HFWorks Manager tree. Let's apply the material for each body. Click on the plus sign next to the comb line filter cavity folder. Right-click on Cavity 1 to apply air. Right-click on Boss Extrude 2 and 3 and apply Teflon. The rest of the parts are just copper. Right-click and apply copper. Let's apply the necessary boundary conditions. The metallic boundary conditions are implicitly applied through the application of copper material. We are left only with the port's boundary conditions. Right-click on Boundary Conditions and choose Port. Apply Port 1 on the circular face of Teflon part. It is a simple wave port. Click OK. Apply Port 2 on the other circular face of Teflon part. It is also a simple wave port. Click OK. All the pre-processing is now complete, and we are ready to run the study. Right-click on the power handling study and choose Run. Solving will take time. Let's instead examine an existing study that was run previously. After the run is complete, results folder is created and contains different type of results. Circuit parameters folder contains the results table and 2D plots. Electric field and magnetic field folders contain the near electric and magnetic fields in the entire model. Port fields folder contains the electric and magnetic fields on the ports. Loss density and total loss folders contain the volume and surface losses inside the structure. Double-click on the results table. It contains all circuit parameters for all frequencies. Click OK. Right-click on the Plots folder and add a new 2D plot. Choose S11 from Parameters and click Add. Choose S12 from Parameters and click Add. Click OK. The plots of S11 and S12 versus frequency appear. Clearly this filter resonates around 887 MHz, as expected. From the electric field folder, we can create different types of plots: fringe, vector, or streamline. To show the fringe plot of the electric field, right-click and choose Fringe. Excite port 1 and port 2 with 1 watt power. Click OK. The magnitude of the electric field is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. The high electric field zone is inside the structure, which is hidden by the metallic enclosure. Right-click and choose Section Clipping. Clearly the electric field strength is well below the air breakdown of 3 million volts per meter. Double-click on 1000 watts icon. This time the maximum electric field strength is 1.57 million volts per meter. It is still below the breakdown but not far from it. Double-click on 2000 watts icon. It is closer to the breakdown but not quite. Double-click on 4000 watts icon. At 4000 watts, the maximum electric field strength is 3.15 million volts per meter. At this level a breakdown is bounded to occur. Let's take exactly the same steps, but use the safety factor instead of electric field. At 1 watt the maximum safety factor is around 0.1. It is around 0.63 at 1000 watts. It is around 0.89 at 2000 watts. It is around 1.26 at 4000 watts, an ultimate breakdown. Consequently, both the electric field and safety factor plots arrive to the same conclusion. It is far easier and more productive to use the safety factor. By the way, you can animate the section plots versus cuts, as shown. The vector plot of the electric field is also at your fingertip. Using the breakdown criterion may not be enough. You must check the temperature rise as well. To do so, right-click on the coupling cases and choose Steady State. Enter 1000 watts at each port and make sure that the dielectric and conductor losses are checked. Click OK. Right-click on the coupling case 1 and choose Run. Again, it will take time. Let's instead examine an already ran case. Right-click on the temperature folder and add a new plot. Check Show Plot Only on selected entities and choose the inner rod, as shown. Clearly, a temperature around 228 Celsius is reached. We know that at 2000 watts there is no breakdown, but at that power level the temperature is high due to the dielectric and conductor losses. At a temperature of 228 Celsius, there is no copper meltdown. However, such temperature may be too high for certain applications. It is up to you, the designer, to decide. Bottom line, you need both the breakdown and the thermal analyses to decide on the power handling of your filter or other devices. You can also run a transient thermal analysis. To do so, right-click on the coupling cases and choose Transient Thermal. Again, specify 2000 watts at each port. Specify 60 seconds for the end time and 10 seconds for the time increment, and make sure that dielectric and conductor losses are checked. Right-click on the coupling case 2 and choose Run. Again, it will take time. Let's instead examine an already ran case. Right-click on the temperature folder and add a new plot. Check Show Plot Only on selected entities and choose the inner rod, as shown. Choose the second time step. When you select a different step, the temperature obviously changes. Click OK. Right-click on the temperature icon and animate, as shown. To better visualize the animation, move the cursor to the left to slow it down. Again, depending on your thermal requirements, you may or may not deem it safe. Another important plot readily available at your fingertip is the losses plot. Right-click on the losses density folder and choose volume loss density or surface loss density. The volume loss density is due to dielectric losses, whereas the surface loss density is due to conductor losses. Last but not least, you may generate a report that summarizes all of your work. Right-click on Reports folder and generate. Customize your report and choose either HTML or Words format. Click OK. The report shall have all the information about your study. Hence, the power handling of your filter or other high-frequency devices depends both on the breakdown, or the safety factor, and the temperature rise. HFWorks gives you both. A tool like HFWorks is indispensable to achieve a design that respects the power handling capabilities without overdesigning. You cannot guess it. You must simulate it. Thank you for attending this webinar and hope to see you in future webinars.
Thank you everyone for bearing with us. And I hope that you have learned enough from the feature technical presentation. Let me briefly touch upon the licensing structure offered by HFWorks. We offer 3 different programs: commercial, academic, and startup programs. Each program has its own benefits and requirements. For the commercial program, we offer perpetual licenses. Our licensing structure is usually annual based. For the rest of the programs, we have a combination of free and paid licenses for students, academics, mentors, lecturers, and professors based on the program they choose. For startups, we offer a very interesting and generous program that saves you money for other startup expenditures. Learning resources. HFWorks offers you various free learning resources, a standard help and step-by-step tutorials, a demo viewer that gives you a head start by accessing many predefined examples and tutorials, regular webinar series on trending electromagnetic topics. Like today's webinar, we regularly post several application notes, blogs, and videos on our web page and social media channels. An annual user conference where you can exchange views and experience with other fellow users. Paid and free web and in-person training. Monthly newsletter to update you about the latest releases, webinars, and other activities. Support and services. Our support service is the strongest point that I can mention in this presentation. We always have your back before and after sales. We offer one-to-one web demo sessions to give you a head start and shorten your learning curve. We may even run a benchmark for you if you want to skip the trial option. We offer consulting and design engineering services. We may even propose to you a new design as per your requirement or refine and optimize your existing design. Featured customers. These are just few of our respective clients. These big names, that come from various industries, are true testimonial for the quality of our products and services. I encourage every one of you to try our software and experience its power and ease of use. We offer 2 weeks of free trial license. You may opt for a benchmark instead of a trial license. Please visit our webpage at www.emworks.com. Go to our Contact Us page, fill in your information and submit your request. We will contact you promptly. On behalf of HFWorks, I would like to thank you all for attending this webinar. Feel free to contact us after this webinar to get more information on our products. Now we pass to the questions and answers period. Please type your question in the chat section on the right of the screen. I kindly request Dr. Kabir to go on stage and answer the questions.